this video, we are going to learn what is a Fourier series expansion for this function in the interval 0 to 3, and after that we will reduce this expression. First thing, we need to observe the function. So function in this case is equal to 2x minus x square, and interval is given as 0 to 3. So we can say that the value of a is equal to 0 and the value of b is equal to 3. What is the length of the interval? That is b minus a is equal to 3. So the Fourier series can be written as a naught by 2 plus summation n from 1 to infinity an cos of 2n pi x divided by length of the interval, that is 3, plus summation n from 1 to infinity bn sine of 2n pi x divided by the length of the interval, that is 3, where a naught is calculated as 2 upon length of the interval 3 integration from 0 to 3 of the given function with respect to x. This is equal to 2 by 3 integration of 0 to 3. What is the function in this case? That is 2x minus x square. This is equal to 2 by 3 integration of this function, that is 2x square by 2 minus x square integration is x cube by 3. Limits are 0 to 3. This is further is equal to 2 by 3. Simplified form of this one is x square minus x cube by 3. Now substitute the upper limit. 3 square is 9 minus 3 cube is 27 divided by 3, that is the upper limit value, minus lower limit. When you substitute 0 over here, we are getting 0 in this case. So this is equal to 27 by 3 is 9. 9 minus 9 is 0. So overall in this case we are getting answer as a 0. So hence in this case the value of a naught is 0. Now let's calculate the value of an. An is calculated as 2 upon length of the interval, that is 3, integration from 0 to 3 function multiplied by cos of 2n pi into x divided by the length of the interval 3 in this case. This is equal to 2 by 3. Substitute the function value. So in this case the function is 2x minus x square multiplied by cos 2n pi x by 3. Now how to find the integration in this case? So observe that we have two functions and both are depending upon x. So we are going to use the isolate function. So according to the isolate, a comes earlier than the trigonometric, where a is an algebraic function and t stands for the trigonometric function. So in this case, we will take this as the first function and this is as the second function. So according to the isolate, suppose we have two functions u and v, and this is the first function and v is the second function. In this case, the integration is evaluated as first function as it is. Take the integration of second function, suppose it is a v1, then minus derivative of first function, then take the integration of this v1, suppose that is v2, plus take the derivative of this term, so that will be the second order derivative of first function. Again take the integration of v2, suppose it is a v3, minus take the derivative of this term, that will be the third order derivative of first function. Then again take the integration of v3, suppose it is a v4. Repeat this process until and unless we are not getting derivative as a 0. In this case we have 2 by 3 as it is, first function, then integration of second function. Integration of cos is sine of 2n pi x by 3 divided by coefficient of x. What is the coefficient of x in this case? That is 2n pi by 3. So this is the value of v1 according to this. Minus derivative of this, that is 2 minus 2x. Integration of this term is, that is minus cos of 2n pi x divided by 3 divided by coefficient of x, and the same coefficient we have over here. So now it gets as 2n pi by 3 whole square plus derivative of this term, that is minus 2. Then integration of this term, that is minus sine 2n pi x by 3 divided by 2n pi by 3 cube. Here we have taken this negative sign as it is. Integration of cos is sine divided by the coefficient of x, and we have already that term here 2 times, so it will becomes as a power 3 in this case. Next term is minus derivative of this one is 0, so there is no need to take the next term. Therefore, we are binding the I8 over here, and the limits are from 0 to 3. Now, before substituting the limits, let's observe the behavior of sine and cos on upper limit as well as a lower limit. So, sine 2n pi x by 3 at upper limit when x is equal to 3. We have sine 2n pi, because that 3 will get cancelled with 3, and sine n pi is 0 as well as sine 2n pi is 0. Now, what is the lower limit? X is equal to 0. So, we have in this case sine 0. Sine 0 is 0. It means this term is getting 0 on upper limit as well as lower limit. So, we will not take this term in the next step. Or we can directly say that it is getting a 0 for both the limits. Similarly, we have same expression in the third term. Again, it is getting a 0 for both the limits. So, we can write this as equal to 0. Next, check the behavior of cos function. Cos 2n pi by 3 into x. Its upper limit when x is equal to 3. So, cos of 2n pi. Now, cos n pi is, that is minus 1 raised to power n. So, cos 2n pi is minus 1 raised to power 2n. This is equal to 1. Why? Because this is the even number as multiplied by 2, and n is any positive integer. So 2 into any positive integer is an even number, and minus 1 raised to power even is 1. Similarly, observe the behavior at the lower limit. When we take x is equal to 0, we have cos of 0, and cos of 0 is 1. So if you observe that this quantity is getting a 1 for both the limits, so in the next step, rather than taking a cos 2n pi x by 3, we can directly write this is equal to 1. From here we have 2 by 3. Negative negative is a positive. This quantity is as it is, 2 minus 2x. This is a 1 divided by 2n pi by 3 square. Limits are 0 to 3. This is equal to 2 by 3, as it is not depending upon x. So take this quantity outside. So we can write this is equal to 3 by 2n pi whole square into 2 minus 2x from 0 to 3. Now substitute the upper limit as well as the lower limit in this case. So we have 2 by 3 into 3 by 2n pi whole square into Upper limit is 2 minus 6, that is minus 4, minus lower limit is 2. So this is equal to 2 by 3 into 3 into 3 divided by 2 and pi, 2 and pi, and this quantity is minus 6. So 3 is get cancelled with 3, 2 with 2, as well as 2 is get cancelled with 6, and we have 3 over here. Final expression is 3 into 3 is 9 and 1 negative sign divided by n square and pi square. And this is the final value of an in this case. Now let's calculate the expression of bn. So bn is calculated as 2 upon b minus a, that is the length of the interval, in this case is 3, integration from 0 to 3, function into sine of 2 n pi x divided by length of the interval 3. In this case the function value is 2x minus x square. And rest of the quantities are same. Now again we have two functions of x, so we are going to use the isolate. So according to that, this is the first function and this is the second function. This is equal to 2 by 3. First function is as it is. Integration of sine is minus cos 2n pi by 3 into x divided by coefficient of x, that is 2n pi by 3, minus derivative of this, that is 2 minus 2x. Integration of this term is cos integration is sine. So we will take this negative sign as it is. Sine of 2n pi by 3 into x divided by coefficient of x, that is also available over here. So it is getting 2n pi by 3 whole square plus derivative of this one is minus 2. Again take the integration of this term. So integration of sine is minus cos. So 1 minus is already there. So we can write plus cos 2n pi by 3 into x divided by coefficient of x, and already 2 times of that coefficient available over here. So this is equal to 2n pi by 3 cube. Next term is a derivative of this term. Derivative of this term is 0. Therefore, we are not taking the next term. Now limits are from 0 to 3. Again, observe the behavior. We are getting a same angle, and previously we have learned that cos of 2n pi by 3 into x, when x is equal to 3, we are getting a value as a 1. When x is equal to 0, it has a value 1. And for sine 2n pi by 3 into x, at upper limit x is equal to 3, it is getting 0, and for lower limit also getting 0. So it means there's no need to take this term in the next step. We can directly write this as a 0 over here. And in terms of cos 2n pi x by 3, that we will write it as a 1 in the next step, because it is getting 1 for both the limit. If it is not getting a same number for both limit, then we will take it next step. This is equal to 2 by 3 negative sign of 2x minus x square. This quantity is 1. Now we can take this as 3 by 2 and pi. Then over here minus 2. This is 1. It is multiplied by 3 by 2n pi whole cube. Lower limit is 0, upper limit is 3. This is equal to 2 by 3. Substitute upper limit. So we have minus 2 into 3 is 6, minus 3 square is 9. So it is a minus 3. Minus 3 into 3 is minus 9. And already minus is over here. So it is a plus 9 by 2 n pi for the upper limit. And it contains no x. So this term is as it is. Minus lower limit. So 0 into something is a 0. Minus this quantity is as it is because it is not depending upon x. Simplify this, we have 2 by 3, 9 by 2 n pi minus twice of 3 upon 2 n pi whole cube. Negative negative is positive. Twice of 3 upon 2 n pi whole cube. This expression is cancelled out with this one. Finally, we have 2 is cancelled with 2 and here we have 3 by n pi. And this is the value of Bn in this case. So finally, the Fourier series is equal to the value of A naught is 0 plus summation n from 1 to infinity. An is minus 9 upon n square pi square cos of 2n pi x by 3 plus summation n from 1 to infinity. Bn is 3 upon n pi sine of 2n pi x by 3. More simplified form is this minus 9 and pi square is not depending upon the index n, so we can take it as outside. So minus 9 pi square summation n from 1 to infinity 1 upon n square cos of 2n pi x by 3 plus, and in this case 3 is not depending upon n as well as pi is not depending upon n, so we can take this outside. Summation n from 1 to infinity 1 upon n sine of 2n pi x by 3. Further, the question is find this expression from the Fourier series. So in this case we have 1 upon 1 square, 1 upon 2 square, 1 upon 3 square, 1 upon 4 square. It means we need 1 upon n square expression from the Fourier series. So let's look at where we have 1 upon n square. In this case we have 1 upon n square, but over here we have 1 by n. So we need to make this term as a 0 before finding that expression. How to make that a 0? We can substitute the value x in such a way that this term is getting 0, so that automatically the summation value is 0. Now, for what value of x the sign expression is 0? Before that, observe the question. In question, we have this function with 0 to 3. And whenever we are finding the Fourier series, it means that function is a periodic with the period 3, that is the length of the interval. So after this one and before this one, the same function is repeated. So if you observe from the graph, the dotted line represented the original function, that is 2x minus x square from the interval 0 to 3, and the same graph we have from minus 3 to 0. So at point 0 we have discontinuity because from the left side we are getting as a limit as minus 3, from right side we are getting the value as a 0. So it means the function has discontinuity at a 0. Similarly, at the point 3, we have a discontinuity because from the left side, we are getting the function value as a minus 3. And from the right side, when we draw the same curve over here, the right side function value is 0. So it means there is a discontinuity at a 0 and 3. From graph, we get to know that at point 0 and 3, this function has a discontinuity. In such cases, we will try to find a x from this interval such that this quantity becomes 0. For that, we will observe this function. We know that sine n pi is 0. We will try to create this as a n pi for value of x. So we have in this case as sine 2 n pi by 3 into x. How you will convert this into n pi? So if we substitute x is equal to 3 by 2, we will get sine n pi, and in that case we can write this as equal to 0, and hence the summation is 0. We can only deal with 1 by n square. Before that, check whether this 3 by 2 is a part of this interval. Yes, because this is 1.5 and it is a part of interval, so we can take x is equal to 3 by 2. Now let's observe whether we are getting the required series with the help of x is equal to 3 by 2 or not. So substitute x is equal to 3 by 2. The function value is 2x minus x square. Put x is equal to 3 by 2. We have 2 into 3 by 2 minus 3 by 2 square, that is equal to 3 minus 9 by 4, that is equal to 12 minus 9 by 4, that is 3 by 4. On the left hand side, when we put x is equal to 3 by 2, we have 3 by 4, that is equal to minus 9 by pi square summation n from 1 to infinity 1 by n square into cos of n pi. After substituting x as 3 by 2, here we have n pi plus 3 by pi summation n from 1 to infinity 1 by n sine of n pi. This is equal to 3 by 4 is equal to minus 9 by pi square summation n from 1 to infinity 1 upon n square, and the value of cos n pi is minus 1 raised to power n. Sin n pi is 0. So 0 into something is 0. So this summation is equal to 0. Next, expand this summation. If you expand this one, we have 9 upon pi square as it is. Put n is equal to 1. We have minus 1 raised to power 1 upon 1 square plus n is equal to 2, that is minus 1 square upon 2 square plus n is equal to 3 minus 1 raised to power 3 by 3 square. Continue. This implies 3 by 4 is equal to minus 9 by pi square into minus 1 raised to power 1 is minus 1 upon 1 square. This is plus 1 upon 2 square, then minus 1 upon 3 square. Next term is a positive 1 upon 4 square. Next is minus 1 upon 5 square. So we have this type of a pattern. Simplify this. This implies pi square into 3 divided by 4 into 9 is equal to, multiply negative sign with this series. We have 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square and so on. From here, what we have? We have pi square by 12. So we can say that this summation is equal to pi square by 12. And that is the required series. Now observe the Fourier series from this graph. If you observe that the dotted line defines the original graph, and this is the Fourier series approximation of the periodic function. Now if we take n is equal to 2, in that case we are getting the Fourier series approximation by this form. For n is equal to 3 we have this, n is equal to 4 we have this approximation, n is equal to 5, 6, 7, 8 and so on. So we can see that as n is increasing, we are getting a more approximate value